Weird. I had some issue with YouTube. Let's see if this works. Let's see if this works. Then we'll continue where we left off yesterday. Gotta be interesting. I did some work at the coffee shop, which is I guess where I do most of my work these days. So we'll see. We're gonna catch up. Wait for a couple of people to join. Then I'll show you where I'm at. I've also got a Manus page to do to track where things are at, which I guess I'll link into the web page. And we're gonna do 2 hours, I think. 2 hours of stream. Gonna be fun. Gonna go make some tea and then I'll start. It's Monday morning is an interesting time to stream, huh? An interesting time to stream. Let me see if this guy's still alive. All right, all right, all right, all right. This is where we left off yesterday. I don't think I can zoom into this thing, but all right. Finishing the tea, and then we'll go over what we were doing yesterday. See where we left off. We had the issue that ChatGPT, the API, was like constantly disconnecting yesterday. That's when I wrapped it up. But right now, we're continuing. It should be Monday morning. Should be like faster, hopefully. So we'll see. But first, my tea, because caffeine. And then I'm really curious how far we'll get today, because things are coalescing a little bit. I know oh my God, it's happening again. That's crazy. Um, but we'll get there. And then I think we have stream.veryclever.ai, which I just had Manus build. So I'm gonna log in and see if I can like kind of control it. Doesn't seem to work. Well, that's cool. Also, my cat is yelling, which I hate. Let me see if I need to publish the latest version. Oh, I didn't publish the latest version. Why does the admin view not seem to work? I really wonder if this is worth salvaging, but we'll see. Admin login. After admin login, I still only see the public view. Admin takes me back to the login dialog. My cat is doing some fuck shit because I just arrived. So we'll see. First get my coffee and then I'll walk you through where we were at yesterday and then we'll go from there. So let me put this beauty back and 2 minutes. All right. Got some treats. Treats for the cat. Treats for the cat boy. You ready, my boy? Come on. All right, hopefully that keeps him quiet for a little bit. All right, so where were we yesterday? I went over how much I love my tablet to do work. I'm at the coffee shop, I do work. And what we're building right now is ultimately I want to build an orchestrator for my Zigbee network. The fuck? The fire alarm is going off. So I guess I'm going to have to go check what it is about. All right, well, I guess the fire alarm's going, so I'm going to have to disconnect this shit. And we'll see you later. Well, that was an adventure. Burst pipe. And guess we're back now, finally. We're back, baby. Hopefully it's not gonna happen again. That would be shitty. All right, let me catch my breath. What we were doing yesterday, we were playing with Zigbee, and we did have a JavaScript VM running to do some Zigbee experiments. Then codex never stopped, crashing all the time. This was the last prompt we entered. Permit join worked when called with CLI bridge broker, but not from the JS. I also want to see more logging from the JS. First, make a test script to test the logging, then make a test script that console prints real time during permit join. And then we can debug the logging things, right? Like, so test the logging test script, then the permit. Then if that works, the permit join. And then if the permit join script runs, we'll then use the power plug, set it into pairing mode, and then continue. All right. What an adventure. That was fun. So we can see it's logging things, so that's cool. And then I have a whole set of things to try out, right? So here it published the latest version. All right, so we can test this, can see if we're logged in. Hopefully this works now. Doesn't seem to work. So I think I'm gonna stop it here. Because I don't think we're gonna get anywhere here. Great news. Should be able. No, I'm not seeing the admin view. Can I only see the public view. I think this is when it's starting to degrade. I had some thoughts about it this morning as well, which is like, how do you recognize, because it's easier to start stuff from scratch these days, right? Because of LLMs. At some point, if you think about it, you have your code base and you can prompt it, fix this, and continue working on the code base. You can take the same code base context, the same tools, and you can say like, hey, use that as a spec and re-implement it, right? So, all right, we're going to increase this to 120 seconds or 60 seconds and tail the logs running in tmux. All right, let's see what happens. I'm going to put the power plug into pairing mode. Which I think it is now. Yeah, it's blinking slowly. And then we're going to start to put on the turbo. Because it's Monday, I'm going to be able to do a few things in parallel. So that's going to be a pretty fun experience. I'm going to go to my project, push everything, and oh, it was running in tmux and then it stopped, huh? Actually, I think we need to restart the bridge. And a couple of things we're going to work on, because we were on this ticket called ticket 67. I'm sorry for the flashing. Where is my code. All right, here we are on ticket 67 it's working on, or like, I guess ticket 70 for the JS runtime. But we do have a couple of other tickets that we can look at. So let me show you those. I can just do doc manager API serve on port 6002, and then we can go on port 7002. I'm sorry. And we can see all the tickets. And then in the tickets, we currently are working on the JS runtime. We had been working in the past on the Zigbee power plug. This was like the first pass, right? And then we can go look in here, see if there's any tasks open. There's not, so we can kind of close the ticket, right? So we can do manage a ticket close, and then we can do 067 Zigbee power plug. There we go. So this ticket is now closed. I think you do have to do refresh here. It's not the best view. And Zigbee 67 has been closed. It's marked as complete. We're working on the JS runtime, but we had been working on the past firmware, which is something I've reviewed this morning at the coffee shop, or at least started to review it. And then we have the Zigbee sniffer go side, right? And so the Zigbee sniffer go side is maybe the first thing I'll use to start a new work tree. So in order to do that, I am discovering this. I'm going to create a new work tree with the repos ESP32S3M5, the repo glazed, and the repo goja. I think that's going to be enough. And then I'm going to do Zigbee add sniffing. Gonna go in here, gonna go into this workspace, doc manager, initialize to save our tickets in ESP32 S3M5, since we're a multi-repo, basically, right? And then what I'm going to do here, I'm going to start a codex. Actually, permissions. Giving it full permissions. And we're now going to be doing work on doc manager 0067 68, sorry. So 68 Zigbee sniffing. And let's start with analyzing the NRF firmware and the protocol it uses for the sniffing. So we do have a chip connected here. Where's the little gizmo boy? It's right here. We have this little guy here, which has a custom firmware which allows it to do Zigbee sniffing. So we're gonna look at the firmware for this dude, right? ASA NRF sniffer. We're gonna analyze the firmware to get the protocol. So here's the source code, right? So we're gonna starting points and git clone, and then I cloned this. Do an in-depth analysis and research and write a full detailed textbook about the sniffer firmware, how it works, the Zigbee fundamentals at play, and especially how to interact with the sniffer, which protocol it uses, frames, and data format. Use prose paragraphs, call out for fundamentals, pseudocode, link to locations in source, use diagrams, bullet point lists, be very detailed as if written by Peter Norvig, store in the ticket, keep a frequently updated research diary, then upload to Remarkable and commit to Git. So our standard workflow, right? It's like I have a work tree now where I'm going to explore the sniffing. I'm going to explore the sniffing firmware, while at the same time we are working here on like much more code-oriented stuff, right? And since we are going to analyze the past firmware, what I'm going to do now is analyze all the work I did on this guy here, which is going to be the device that our orchestrator is going to be using to do Zigbee. So at the same time here, I'm just going to go back. I'm going to give it all access, and I'm going to say work on doc manager ticket 0069, analyze past firmware, and create a new in-depth exploration and reference of the actual H2 firmware and NCP protocol and how to use it from a host device. Be very detailed. And here we might use some Opus to polish these things up, just because why not? Look at the firmware as well. So I think we do have the firmware cloned here. I don't know, man. This is kind of starting to be a mess. Store the detailed exploration reference textbook document in the ticket. Keep a frequent detailed research diary. Upload to Remarkable and then commit to Git. So same here, we're just using our doc manager skill, just have it start doing like 3 things in parallel. And so this is, if you go back to my tablet, this is kind of what I have. So what we're working on yesterday and today is the 0070 JS API is one of the tickets we're working on. And then the 0067 Zigbee power plug, we just closed it. So I can check it off. You can't see this updating. Here I checked it off. I created this new ticket. And what I launched here is one thing I could do is create a playbook to use Zig control. I'm going to leave that out. I don't think we really need it right now. This is going to be the JS VM work we got to do. And there's like little sub projects that I need to work out. So I think console logging, we got it. The SQLite module, I think we need it. So console logging, I think we got this. And then here, it received the permit join. It received the join thing here as well. Print bridge event messages, and even when no join. I'm not sure it saw the device appear. So I know we tested it yesterday with the go command. That was working. So that would be interesting. So we're going to say, did you see the power plug appear? Print the bridge, and then use please confirm in a script to wait before running the JS. Continue storing all temp scripts in the ticket. If you are unsure, please confirm help how to use. Make sure to read in full. All right, it's because we're going to use this little system here so that I have time to basically turn the plug on and to request to join mode, which it might have missed, right? Like the problem is codex is so slow that it's hard to know if it'll actually get to the command within the interval that it's supposed to be. I think it is in request joining mode. I see it blinking a little bit. That part is always annoying. So we'll see where it gets to. So we have a bunch of things going, right? We have, if we look here, we're currently on the 0069 analyze the old firmware. We have this running, analyze old firmware. So that's a ticket. So it goes into red. And then we have here the model going into analyzing. Then we have to review it. So red for ticket. The sniffing is 68. Analyzing firmware is 69. So here we have it analyzing, then in green, actions that I need to take. And we're going to take the sniffing part and move it into a new page, right? So I already worked this out a little bit. So we're going to take this, put it onto a new page. And we're going to work on here. So one thing we did with the sniffing right now is we're analyzing the NRF serial protocol plus firmware. So that's where we're at right now, right? It's the model doing this. It found the code source base, so that's good. And then we do have to have it do a document, and then we have to do it, review the document. So this is done. Then this is kind of ongoing right now. And in green, what we'll have to do is review, and then we'll have to create a design document. Once we have learned how the protocol works, we're going to have to review design document for communicating with the sniffer. That would be like the first part. Review, then implement a Go version, validate. And are we seeing the, oh my God, I hope we're not going to have too many disconnect errors. It could also be that maybe this session is cursed, because I'm not sure if the other ones are having these issues. Maybe the session's cursed. We should get like a notification when it's asking us feedback. So hopefully we'll see that. And going back to this guy here, going to put stuff that I need to prompt is in yellow. Then stuff that the model needs to do is in blue. Analyze plus write. Right, actually like this. We're currently here. Creating the tasks from the design doc. I think the design doc might have been a little bit too early because we didn't analyze the serial protocol just yet. What's the plume confirm? Please confirm. That's weird that it like mistook that. And we create a skill out of this, right? So creating a skill out of what we're currently doing is still in the JS VM 0070. We're still doing a testing. So we're going to move the 069 to its own page as well. So 069 is going to be here. So this is the old firmware. Old NCP H2 firmware. And then on the JavaScript, the current task that we're doing is like test permit join with JS event logging. And because we decided to use please confirm, we decided to use please confirm write skill for using please confirm. So those are prompts that I need to do. And this is currently what we're at. And then we're going to do a postmortem, right? Write a postmortem. Review the postmortem. And then reviewing the postmortem will allow us to improve either documentation or APIs or skills and take actions if needed. So this expanding of tasks as I go, right, is something that I do want to formalize because they're basically transformation of the task graph that I keep doing over and over. And so I think there's something to be formalized there to make it easier to share them, to repeat them, to keep track of them. So I'm still unclear if it like actually tried to run it. Also, the context window spilled over. I think it's time to start cleaning up this thing here at the top. I'm going to have it write whatever it's doing, and then I'm going to start a new session. All right. It's doing the changelog. Add PLS confirm gate for JS permit join script. What does that mean? So if I look for PS confirm, it's like walk through MLAT protocol, diary, pair debug. So this is all not stuff that I want to have. This is the one. Harden PLZ confirm. All right, so this looks good, right? There's a is that right? All right, we can see. It created a script. We should be able to run this script and then see what happens. This is burning through a lot of previous documentation and source code, right? So I expect it to burn a lot of context. The thing is that the document we have now is like kind of a shortcut map for stuff we might want to do in the future. I've got some trackball issues. I'm going to try to fix those. That's like one of the disadvantages of having moved my lab out is that I don't have many tools left. So we'll see. We'll see what this dude tells us. Because I have grubby, dirty hands. It's weird. It doesn't look all that grubby. But who knows? Maybe I should do a deep clean at some point. All right, let's see if that helped. And yeah, we're back, baby. All right. So it's going to run the script. This guy, the H2NCP protocol reference has been uploaded. And what we're going to do now is like add a raw host non-ESP sample implementation in Go, right? So make a detailed design document for adding NCP ZNSP slip decoding in Go as part of the zig control framework and sketching out pseudocode plus API of it. No real code yet. Design doc, commit, diary, upload to remarkable. Upload, keep a diary. So we're starting to design this out, and then we'll make a script. So you can see please confirm is like kicking in, right? Like it's telling me run the watcher. I'm going to put my plug into permit join mode. Come on, start blinking, and then I can press run confirm. Hopefully it's blinking. Yep. And so now I can do it. This actually unlocks the script. For some reason, it finished immediately. It looks like you immediately exited from please confirm. I approved the join. So see, you can see the request here. We're still in proofing things. So now it fixed the script. We're definitely blinking right now. It still seems to be buggy in the script wise, but you can see how it's supposed to work, right? And so because it's struggling so much with all of the test stuff here, I'm going to have it updated still, right? Like I'm going to do the postmortem and use the postmortem information to basically avoid all of this in the future. And the way I think about it is like skill is kind of like cached computation, right? So we'll see all the fixes that it did. This guy is still in like permit join mode. Hopefully this will work. Diagnosing STD conflict. So the script is like messy. And that's why ultimately I want to have the JavaScript is to avoid all this kind of like messy stuff, which brings me to another idea for the JavaScript VM, which is like add please confirm library. All right, so we're still going to run the watcher, still in blinking mode. And we'll see what comes out here. So now you can see it found it, which is sick. Right, so that worked. It took us a few attempts, but now we not only have a script to look at, but we can create a playbook, create a skill out of it, create a postmortem. So I'm going to start having it, right, like create a detailed postmortem report that shows all the technical issues we ran into, why they happened, what we did to fix them, and what we should do better in the future. Also, continue keeping your diary and backfill if necessary. Commit all this and upload the documents to Remarkable. Right, so I'm gonna queue this. We've had a permit join run from JavaScript. This was cool. This is continuing to analyze and design a new Go part to interact with the sniffer. My trackball is still weird. And then at the same time here, we did have the sniffer and the document, and then it will then we'll review that, right? So if we look at the stuff, by the way, this is like kind of fun to look at the request history. Excuse me. Which you can see here. Still very much a vibe code tool. I haven't done like shit to it, but it's really useful to have like richer forms. You can do things like table requests for multi-selects, for example. You can have it show like images. I don't know if there's like a skip thing. Maybe there was something that I still needed to add. Fuck, now it's stuck. that was bad. All right, well, it's gone. So we have a postmortem. We have a lot of documents to review right now. So if we look at the documents we have to review, and we kind of go to the JS VM, we're going to have the postmortem for testing the permit join. We had this. It's doing the postmortem right now. That was one of the things we had. And then we were doing analyze the H2 firmware with MCP command. This is actually going to be ticket 690069. And this is written out on the page. Oh, it's 0069. Yep, it's on page 5. So I'm just going to note this down here on page 5. We did extend Zig control. We have a design for it. And then we're going to see if we can do the event-driven stuff later on. So actually what I'm going to do is I'm just going to cut this out, move it to page 5. And be here, right? So which document are we going to review first? I will probably review I'm probably going to review this guy here. We can start a new work tree to do it. And then here we also have work to do. So the protocol deep dive is maybe something interesting as well. So we can go to this analysis, which should now be under 0068 sniffing. You can see it here, and the deep dive is available as a document. I'm reading those on my tablet over here, and I'm basically annotating them, which allows me to then do whatever prompting adjustments I need and then continue. So we're going to go through this, provide a detailed source anchored understanding of the Nordic 802.15.4. It's a Wireshark integrated capture tool built on a small firmware and a host-side XCAP plugin. So where can we find the XCAP plugin? So that's the first question that we can do, right? Did you look at the XCAP plugin? And if not, where can I find its source? And in a way, if you think about what I'm doing right now in the bigger scheme of LLM programming, right? What I'm doing right now is I'm taking the sniffer source, right? I'm taking the XCAP source. I'm going to take some web documentation. I'm taking the XCAP, which is the Wireshark plugin for the sniffer. I'm taking all of these, which is, it's like, it's complex. It's a lot of tokens. It's like, I don't even know how it works. There's only certain parts that we care about. Yes, I read the XCAP plugin source in your local clone. So that's cool. So what we want to do now is looking at Zig control and the other design document for a sniffing part, and then design a Zig control kind of parser interaction tool with the sniffer, right? So looking at other design docs in 0068 and looking at the Zig control source, create a design document that sketches out tooling for Zig control to interact with the NRF chip, so that we can start using it in our coding sessions. I don't know if that makes sense. Be really exhaustive and detailed and write the design doc into Doc Manager and upload to Remarkable commit as well. So what we're doing now is we're taking all of these 3 documents, right? And then here we made like a textbook style analysis document out of it. And the textbook style analysis document, not only is it useful to read, right? So we have like kind of source artifacts, which I'm going to put in blue. So those are raw source artifacts. I'm going to call them raw source artifacts. And out of this, we create like a filtered artifact, which can be reviewed. And it's like a denser, intentful, condensed, human readable is important here as well, document. Because this document I can review and learn from as a human, right? But also for a clanker, this is both like, you know, a reference doc, but it's kind of cached computation. It's the cache computation of all the work that went into creating this document, right? So there's, if we look at it and we kind of extract that part, move it a little bit lower down, what happened here is this whole process of looping with codex. This is a lot of compute, right? Compute, etc., right? And so I think of it as this is a cached version of the computation, and it's also a map of the code base. It is, because it references many other files, right? It is kind of a navigation map for the model to later on work on this code base and start doing things with it. So I'm going to put this in blue. So it has two purposes, right? Like even if the document's not great, I am going to be able to learn from it. And then here it serves as a ref, but it also saves as a map, right? For tools. And so if we go back to this document, maybe it will become a little bit clearer how it is structured. And it doesn't show you the preamble. So this is something I would have to open in another cursor. Now that we created a new workspace, I can go into workspaces for today, add the sniffing. We can open this. And then the document is called 02NRF sniffer. Why is cursor so fucking slow? It's like insane. I mean, maybe it's some of my VS Code extensions as well. 02NRF. See, I'm sure there's something that's going to steal my focus and just close it. All right, so we have the deep dive, and if you look at it, this actually lists related files. So we'll be able to find like different entry points into all of this. It also lists like all the external sources that it used. This is kind of a vibe coded prototype. This is not all that great, but this starts creating like kind of like a code graph, right? How different files are related to each other. And this is the document we're looking at right here. And I'm going to take my red pen. I'm going to look a little bit. There's like commands over the serial file, and then you can see this functions as a graph. I don't know where it's doing the temp SDK NRF, so that's going to be where does temp SDK NRF come from, and move it to the workspace. Actually, I'm not going to move it to the workspace yet. I'm just going to ask where it comes from. Continuing to look at this. So this is this is where most of the value is. It's the fact that I get to explore the system and at least get a high level overview of all the pieces that I'm starting to put into it, right? And so now we also have a design document for how to build a CLI tool around it. That way we will be able to loop back and do some sniffing with our tool without having to manage like T-Shark and all kinds of weird stuff. We can just, all right, cool. So just mention it in the diary if you haven't already. Packet line format, I don't really care about it, although it is interesting. PSDU, what the fuck is that? Include FCS. Like GPT-5 is pretty cryptic. We'll get the power. I don't know what LQE, link quality indicator, source pointers. So this is cool because if I do have a question about PSDU, or I refer to some of the symbol names in here, it will be able to find the source code down here, right? So that means that I can prompt at a high level Zigbee protocol kind of level, and it will be, if it has loaded this document in its context window, it will be able to immediately look at which file is relevant for it, which is really, really important to have it stay grounded in code, right? It's this kind of like semantically rich map of the code base. The host pipeline enumerates USB CDC devices with the VID PID. That's interesting. The XCAP script issues sleep, turns shell echo off, sets channel, sends receive. Okay, cool. So we're going to emulate this in Go. And I don't know why my tablet just crashed. That's great. Just continue doing that, tablet. What the fuck? Is it this guy? It could be that this guy is just like a little bit aggressive. Okay. So anyway, we have the deep dive. Going to go back in. Usage example. This is cool. Like all of this information is going to be really, really useful for our Go program, right? And it's like filtered out of all this like huge code base. We're at 73% context left because it folded something pretty much. And then the pseudocode trick is pretty good because it gives the implementing model enough freedom to do its own decisions about things because it will know more. Opus is always like very fast at writing code, and often that code has like subtle little issues because it just didn't think and know enough about the code base as it's starting to write them in design documents. So here, having the pseudocode is a really useful thing because it's kind of this code without the details, which is nice. The system here is nice. This will teach me a little bit more about how the firmware works. And we do have the firmware, which we can analyze. The UART protocol is what we're going to work on. And this is kind of where we're going to replace this with Zig control, right? So that's where we asked it. I don't know how fast I'm going to skip over this. Like this is kind of technical details that I maybe don't need all that much. This is so fucking annoying. It's like I restart this tablet like 15 times a day. Actually, since I have a shell open, what is going on here? Is it -H? How do I print this? So we have 2 gigabytes in total, and then we have 1.8 gigabytes used. What the fuck? Resize, we have init, system journal D. This is taking 3 gigabytes of virtual space. Yeah, so really it is Zaki control PDF renderer. that's eating all the memory. So I guess I never know how to use system control. It's so annoying. How can I restart? I restarted. It's loading. All right, cool. We can go back. Second, sniffing, deep dive, page 6. Zigbee fundamentals. All right, cool. I don't care about this. So now we have a Zigbee decoder sniffer tooling for coding sessions. So scope, device discovery, serial control protocol, capture pipeline to frame to keep CLI UX for daily use. I'm probably going to skip over this pretty quickly just because it is probably pretty good. We will have to prompt it to use glazed, right? And we do have a skill now, I think. And then detailed CLI design. All right, all of this. So now we're just going to ask it to implement it, right? It's like using glazed. So I hope that we do have a glazed skill. Skills. And we do have a glazed command framework, and looking at others in Zig control, create detailed implementation tasks in the ticket, start working on it. Don't modify other code in this code base if you don't have to. If they're let's remove that. Let's see. I've never really tried merging and doing that kind of thing. So we'll leave it. And if I have merge conflicts, I'll just rewind and do stuff. Work on them, check off tasks one by one, commit as you go, and keep a detailed diary for the control sniff, right? Yeah. Okay. Hopefully this will load the skill, and we'll see how much we struggle with that. But because it already has other commands in Zig control, this is going to be smoother than it was yesterday. So going back to our Zigbee power plug part, right on the left, now we are analyzing, we reviewed it, and now we're saying like we designed Zig control sniff NRF, we reviewed it, and now we're implementing it, right? So this kind of looks like some kind of nonsensical, always the same kind of workflow of like doing plan, analysis, design, implementation, reviewing. But I mean, that's how it is. Like a lot of tasks just fall under this umbrella of being pretty straightforward. The review, of course, is like the key part, right? Like that's where I change a detail or two, go forward with the whole thing. So we have this running. Now we can go back to our other one. If you want the postmortem, upload as separate PDFs instead of a bundle. We don't, but we can go back now and investigate. If you remember, we are on the JavaScript ticket, which I think is page 3 here, on 0070. And we're going to write a skill and postmortem review the postmortem. So we wrote this, we have to review this. And now we're going to say, right, create a skill on how to use PLS confirm to do interactions with the user as part of bigger coding workflows or within scripts when we need to wait or instruct the user. So we're going to create a skill for please confirm. So we're now working on, if I check this off, we're now working on this. It's writing the skill, right? And then hopefully the skill will work. So blue is the machine running. And then we can check this off. We've done our job. We're waiting on writing the skill. Now we can review the postmortem, which is this task, while the other one's running. So reviewing the postmortem, it's going to be in here, ticket 70. We have the postmortem of the JS runtime and permit join validation. And here's going to be some really interesting stuff. So we validated the runtime and the permit join, but we hit several operator workflow issues. Timeout window too short, positional arg ambiguity, which misrouted a timeout into a device field. Okay, that sounds weird. What is that? We fixed each by adjusting timeout, switching to key value parsing. So that might be something to add in a playbook and reference on how to use the JS runtime. And repairing JSON parsing in the confirmation script. So hopefully this will end up in please confirm skill. And as you can notice, I could maybe already have added details to the please confirm skill. So that's like kind of the danger of having it plow ahead too quickly, even with manual review. No device join events were observed during the final permit join window, but the bridge stream showed steady traffic and confirmed permit join responses. Okay, so we do still have a bug. The JS didn't get to see the join. Why? So that's definitely a big deal. We have to add this to our actual tasks here. We're reviewing the postmortem, right? And then here is like analyze and fix the bug where the JS didn't see the join, but the bridge did, right? And this might go into like a bigger issue of like how do events get routed within the Go to the JavaScript. So I'm really going to focus on the analyze, and I'm going to prime this asking for the event flow architecture. And that's maybe something I should have started earlier, right? So these are prompting things. And we'll have a analysis document writing, and then we're going to have to review it, obviously, right? And then fix the bug. And here, very little changes in prompting might cause it to actually catch the bug or not. So things we need to do now is we're reviewing the postmortems still. This is take actions if needed. So we already have actions that we're starting to take. Let me move this to page 6. Just to have a little bit more room. And there we go. We can go back to page 2. Or page 3. Page 3. And we're still reviewing the postmortem, and it's writing the skill. It finished writing the skill, right? So we could start analyzing the end-to-end. So we could start working on this. So we're going to say analyze why the JS didn't see the join event, even though the bridge did at the end focus especially on how events from parsing are created, well, on how um, MQTT stuff makes it to the JS in detail, and if there is an event architecture, and if not, or if it exists, how to use Watermill to do more cogent Go routing to JS with events. This is messiest prompting ever, but I kind of care about the keywords. Research in depth, leave no stone unturned. And I wonder if I do have, this was the interesting part actually. I wonder if I do have something in Manus about a JS bridge to Watermill. Uh, all right, cool. Man, this stuff is so ass. So I guess we don't have that. I'm pretty sure I had like something with Goja and events. Test memory pub sub with so there's this one maybe, and then there's test memory pub sub with 0 log. What was this session about here? This was a long time ago. Leave no stone unturned. Make design suggestions and bug fix analysis, potentially with reproduction scenarios or other things to test. Store as bug report analysis in the ticket and upload to Remarkable. Keep a frequent diary as you investigate. Summary. Approaches for JavaScript event handling. How to get external commands and events. So this is interesting, right? I wonder if this uses Watermill. It does. So this is interesting. This is quite a while ago. We're gonna, same as we did before, we're gonna launder this to do the postmortem. So if I go back to my tasks here, I'm gonna say launder manus. What is it called? Launder manus prototype test transcript agent. With Goja in order to have an analysis of doing events in JS. So I don't know if it's going to be all that useful, right? So we're going to have a review document, and then potentially we can make this flow back into our design for the JavaScript. actually, this was not the right idea. We have the launder, and then we do have some stuff to do by ourselves, and then some stuff that the model then needs to do. So once we have a zip file here, we'll import it into its own Git repo as a temporary Git, and then run the analysis in there. That way we have a separate kind of ticket that we can look at on the tablet. Going back, we are doing the analysis writing, so we can cross off, if we go back here, we can cross off this task of analyzing, fixing the bug. We did prime this with the event flow architecture. It's now currently doing the analysis, then we'll review it. At the same time, this thing is like designing the zig control. It's actually, oh, it's building it. All right, so this is cool. It's building it, and then we can test it later on. We do need to have a new session going on the top one. So this was one of the tickets we're doing. We did write the skill for please confirm. I don't know if it's going to work. Let's continue reviewing the postmortem before we move on. So we were at reviewing the postmortem. We didn't even start. So watch loop timed out, positional args. So that is interesting, right? Like arg passing to JS scripts. I don't really think the current solution is all that great. I'm not really sure how to handle it though. Add to playbook. Yeah, we're going to create a playbook for running JS scripts. So if we go back to our, I wasn't showing what I was doing. Reviewing the postmortem, another thing that I'm going to do is create a playbook to run JS scripts and flesh out the long description of the JS command. So this is also something to prompt that I should not forget. So you can see there's like, this spawns out quite a bit and keeps me quite busy, right? Like even though I don't have that many codexes running, I feel I have a lot of things to add as we go that I definitely don't want the model to choose on its own. So going back to here, where we realize, oh, this would need a playbook. I don't know if the model would have realized, oh, this would need a playbook, but however, this one doesn't, right? The parsing failed. Use the here doc, whatever. No join events. No device was placed in pairing mode. Minimal bridge output when no joins occurred. So we fixed that, right? Or maybe we can also make this a playbook. We'll see. We'll probably need a debug playbook at some point, but I don't know if you want to have the sniffer in there as well or so. Doc manager flag, list format JSON. Yeah, it's output. Added debug logging in the JS runtime behavior and making it easier to see that. Remaining gaps, if device join validation is required, schedule run the operator gated. So it doesn't go into it not seeing it on JS at the end, right? So yeah, so instead of update the JS to do actually update the JS to allow this. So that's another task we should do here. Update the JS script to allow choosing bridge event versus bridge when debugging, and add a big upfront doc string explaining the script and how to use it, including CLI call with the flags. So it's not a great playbook. So then also create a playbook and store in the ticket on how to use JS scripts for debugging, how to call them from the CLI, how to pass args, upload playbook to remarkable. All right, so going back to our thing here, it's going to be this we prompted, this we prompted. So if we go back to our Zigbee power plug thing, we can check this guy off, right? And then this is getting written. So I'm going to put this in blue. We have the analysis doc has been written. So we'll have to review that. So if we go back to this part here, I'm going to check this off. Now we have the review to be doing here. We're going to continue with the existing postmortem though, which is still here, page 2. We're looking at the remaining gaps. This lists all the commands we'll run, and then here we have the diary that is pretty long at this point. We don't care. There's the bug report here that we asked for, so now we can review that. If we go back to, however, to our log document tracking things, we have finished reviewing the postmortem, so we're good. Now we're at this point here, right? So let's do that. Bug report and events. I'm going to switch to the red color. During permit join validation, the JS watch stream showed bridge info logging, but not show device join events, even though Zigbee MQTT logs indicated join related activity. Most likely causes are event timing and topic selections, buffer drop in the JS watch stream during large burst, and 3 different event channels, bridge log versus bridge events versus device topics. The current JS watch architecture is simple and synchronous, and it can drop messages under bursty load. That's why we're going to switch to the watermill thing, right? It's like I thought there was something going on here that wasn't all that great. JS permit join script return status okay and stream bridge state, bridge info, and bridge logging output. No bridge event join messages were seen in the JS stream during the window. Zigbee MQTT showed ongoing device telemetry publishes. A device join should result in Zigbee MQTT bridge event messages, device join, device announce, potential. Permit join returned successfully, no bridge event seen during the same window. So did it not join? Interesting. So this is so annoying because I never know when this power plug is actually in pairing mode. I don't really trust the blinking LED on it. So worth investigating. So we got JS debugging playbook. We're going to continue reading this a little bit though. JS watched output included bridge info, bridge logging, state messages, permit join, returned successfully, no bridge event messages. Hypotheses, join event dropped due to buffer overflow. Printing then in JS is slow. I don't think that's true. Message channel is only size 64. Sounds big though. I don't think that's the case. So can we compare to the raw Zigbee MQTT logs? And for that, I'm going to build my own Go tooling, right? So This, I think, is the more plausible part. I don't think so. So hopefully a better event design can also help. So that's cool, right? Use tmux. Yeah, so I like this. We're going to make this our ticket. So we're going to do two things. Create a debugging playbook from the reproduction and diagnostics plan. So create a new ticket 0070 permit join bug fix, create a debug and add it to the new ticket. I'm going to do this using doc manager, close the current ticket, and add it to the new ticket, add a task to write a reproduction script, use tmux to run things in parallel, add another task to run it, add another task to write a debugging postmortem once you identify what is going on, add a task to upload it to Remarkable, then add a design document on how to refactor to this new ticket, on how to refactor the current setup to use Watermill to do subscriptions and make it easier for the JS to subscribe without having to keep a back pressure channel. Store the document in the ticket, keep a detailed research diary as you go, upload the new ticket bundle. So if we go back to our plan here, what we're doing right here, so we created a playbook to run JS scripts. I haven't reviewed it. We're going to launder the Manus. We'll see what the design doc looks like. We reviewed the analysis of the bug report, and then now we created 0073 bug fix, where we're going to create a repro playbook plus script, and then we're going to run it and get like a bug repro report. So the fix the bug, that's like the intent. I put it in orange. The ticket is going to be in pink. Then the thing we prompted is the repro playbook. And now the model is kind of writing the bug report and running all of this, and then we'll have to review it. So there we go, review. We created a new ticket, bug fix, and we have a bug report, and then here we also have a design for Watermill. Which we also need to review. So this here, and then we have a blue task going. We prompted this. This is ongoing. This is ongoing. And that's the intent here. All right, it's starting to get interesting. We're going to copy this over or cut it over and move it to page 7. Right? Going to go back to page 3 and we're going to mark this 0073 bug fix C page 7. Just to keep some organization and all this like crazy stuff that's happening here. Yes, yes. So this is our sniffer. It's still running, and we're doing the design document, a new ticket, and we have this like third task that we haven't had really gotten a look at, which if we look at it here was the sniffing, right? And so we did the analysis, we did the document, and now we can review it. Then we made like a design document, right? So right now we're here. So that would be something to investigate, and we can look at that in our document here. It's 069 ESP32 serial reference, which it analyzed the firmware for right in our previous thing. I'm not sure this is all that interesting. And this is to communicate with the H2 device over here, which ultimately I want to do from Go, but then later on from JavaScript, and then later on from an ESP32, and then later on from JavaScript on the ESP32, which we'll get into later. So we're going to fork here. Maybe I'll do the pull request of the sniff first, just to get a sense of how bad the conflict is, and then we'll see what happens. So what is it doing? All right, so it found that. So I'm gonna let it like continue to run this and kind of muck with this. So there's issues with the PCAP. Interesting. I'm gonna let this churn a little bit and then have a postmortem. So we're currently at this has created a new ticket to do the bug fix. This has a whole design that we're gonna fork a work tree, but I do first want to merge the sniffer part once it's done, just to get a sense of how complex these things are. We are at 12:30 EST. Maybe this is as good as any a point to stop. I'll definitely have to close the top codex because that one definitely has all these like weird connection issues. We're starting to eat a little bit of stuff. So now we created all of these tickets. It uploaded them to the bundle. So now we can actually look at the. I'm going to close the session here just to make sure. We're going to look at all the stuff it does need to add. So it didn't commit shit, which unable to index file mosquito DB. Okay, cool. So we're gonna go in here. Data log. Okay, cool. So, okay, git add ttemp, and then we're going to push this to main. And we do have a ticket to review all of this, which I think it uploaded to the project still, huh? Git add remarkable upload to 0073 allow bug fix. So if we look in here, this is the bundle that it created, has the permit JS join playbook, reproduce and diagnose case where the JS watch stream does not show events, environment assumptions, start raw MQTT capture, start JS permit join watch in a second terminal, in the zig control directory, put the device into pairing mode immediately after permit join starts, keep it active for at least 10-20 seconds. Success, both JS output and Mosquito sub show join events on bridge event. Failure mode, timing notes, and then the watermill design, MQTT subscriber, watermill router, bridge event, all of these subscribe to the routes, the buffer, pull-based JS stream, keep next to avoid unsafe callbacks into Goja, normalized event envelope, uh, all right. So this all seems pretty good. If we go back to our design document and we had 073, 03 bug fix, we have the bug report, we reviewed it, So now we can do repro the bug using playbook. And then we can also say, maybe this is plan out watermill rewrite, which will become more important as we start piling on all kinds of events, right? In detail. And maybe we should look at the Manus here. But that's going to be for tomorrow. I think we're going to try to get the sniffer merged, updated go work, fix the test failure, ran test successfully as requested, create a playbook on how to use the sniffer, add as a glazed help entry to zig control C glaze is help writing help entries. And actually I do have glazed in here, right? So I can directly reference this. Writing help entry, oops, nope. Writing help entries and how to write good documentation, add to zig control reference in the command long descriptions. Oh, that was another thing, right, which we wanted to have in the JS. But anyway, let's open the pull request. We'll do the rebase after this guy is finished over here. Then we'll open the pull request. And we might call it a day for today. This is going to be a new work tree as well. It's having disconnections here as well. Anyway, plowing our way forward to have a really robust JavaScript thing. And it's all hardware. I have like a sniffer and I have a dongle and I have a device and I have to like do this pairing. It's all like all a little bit complex, which makes it a really good use case to write out a nice JavaScript wrapper, right? Um, so another thing that I want to do, I guess, also for next time is adding a REPL, adding the please confirm lib. That's also a nice idea. There's just so much to be built. And I still don't. Yeah, so this is the stuff that we were starting to look at, right? So this is C0073, page 7. C0073, page 7. So we'll see what that leaves us, I guess, tomorrow. The idea with all of this complexity, though, is that I will expand the concept for anything that has to do with hardware, right? Like this kind of architecture that we're building here, once I start doing USB, once I start doing other protocols, I'll have something to graft onto, right? To We're gonna do a pull request now as well. Add sniffing verbs to zig control. That's because it's too big. Oh, I said I would rebase, but whatever. Why did it not have this? My prescribe tool is not great. Oh no shit, it didn't store any of it. That's interesting. All right, anyway, this is this prescribe tool was also a YOLO vibe and really not convinced it was necessarily the best approach. Kind of was. See, the issue is this dude here. All right. Well, anyway, create pull request from YAML. I didn't even read it. Hold on. Let me look at this. Yeah, let's close this. Add sniff NRF, new sniff NRF core functionality, implementation details. Yeah, so this is good. Create a fork. All right, git remote rename origin Vazen, and then upstream origin. And we can look at the pull request number 1 over here. 30 files changed. This was pretty clean, right? Like it's all contained to here. It adds it to one book over here, and then it has packages. Everything's new. The only thing that changes is the zigbee config, which has a default sniffer config. The sniffer config has also been created as a struct and a layer using the new names for the layer. That's cool. All right, this looks great. This is exactly the kind of one shot that I wanted that's going to merge cleanly. So we're going to merge this, delete, go back to this code here, git PRB, could not reset hard, unable to unlink the log. In fact, this whole thing here excuse me, remove mosquito data. What do you mean I have unmerged files? Permission denied. What is this? All right. Joe, yo, what the fuck? I knew this would cause some fuck shit. Why is this? Your local changes to the following files would be overwritten by merge. I don't get that. What does that mean? Oh, nothing is committed in here? Wait, what the fuck? Well, we didn't have the config sniffer, the command sniff. All of that came from the rebase? That's very weird. Yeah, because all of this is from the sniffer firmware stuff, right? I'm just for safety. Okay. What the fuck? Okay. I don't know what this was about with the rebase. That's why I was like not super keen on on testing this. All right, are we going to have our merge? All right. And then now we're going to do a pull request. No. Hey, yeah. Why are we not going to do a pull request? So there's like nothing interesting here. All right, pushing. Oh, this should be. Does this still compile? All right, and we do have the sniff. All right, we have all of these things, so that's cool. At least we got the merge. What does this here say? Fixed tap TLV emphasizes the length, but the code writes, which makes a tap metadata self-inconsistent. Yeah, so this seems actually kind of interesting. Oh my God, I hate this nonsense. All right, we're here. We could do codex. No. Where was our sniff codex resume? Yes. No sessions yet. Codex resume. Yes. And then fix that. I didn't even create a diary for this. I wonder if it's going to continue adding it or not. Oh, it's against main. The fuck? Oh, I see. I see. I know what's going on. this is where I need to rebase the main. Okay. Fix LTV encoding bug. Why does it fail now? That's so weird. Yeah, I don't know why it started failing, because this is to work at least a little bit. Well, good to know. Eh, it's always this garbage here. All right. Cool. Progress slowly but surely. All right, have fun, guys.